Hello, this is a quick movie about using intervals in graphing. So we're going to look at some results. Let's pretend there's a hard high school test that some students had written. And these are all the numbers. Now, the numbers are scattered all over the place. There's some high, there's some low. And the teacher really wants to take a look at how everyone did. They might want to do some organization. So here's all the numbers organized in a line. Someone might say, well, why don't we graph the results? The problem is when we do graph it, the graph is not going to be too interesting. So what does all this data tell us? At this point, it's hard to know whether or not people did well or not. What we can do is organize some of the data, and that'll give us some insight into how people did. So here's a graph of the data. Again, there's so many numbers. Most people only scored the particular score once. It was only one person who got 77, but there were two people who got 75. But still, it doesn't really give us a lot of information. Graphing numbers like this is not really that helpful. But what if we group some of the numbers together? How could we do that grouping? We could use different intervals or different pots, I used to like to say. Different pots we could use where the different numbers could fall in there. For example, if we use the interval of all the 80s, we could take a look and we could do a different graph where we organize the numbers based on a range of numbers. So in this thing, our whole range is from 5 to 100. In our textbook, would say the range is 95, but the lowest number is 5, the biggest number is 100. We want to put the related numbers together, and we want them to be into about 5 to 10 intervals usually. Let's use different intervals to group these numbers. So again, the range is 5 to 100. Can we make, let's say, about 10 intervals? So let's make 10 intervals up to 100. So we could start perhaps at 1 and go 1 to 10, 11 to 20, 21 to 30, etc., up to 100. This way, all of the numbers will fall within one of these intervals. So if we reorganize the information, we find that the interval of 70 to 80 and 80 to 90 where a lot of the kids fell. But some of the kids fell at different numbers in the range. This is kind of a way now that at least we can do this graph, looking at the intervals, and we can get a better idea perhaps of where the kids, where the majority of the kids fell for the test. And if I did the graph, it might end up something like this. So now I could say that, well, I see a lot of kids were 71 and above, but I also got some kids kind of in the middle and a few kids down at the end as well. So just for a review, you look at the range. The really important number could be the upper number, because that would tell you how high you have to go. The lower number would tell you perhaps what the lowest interval has to be like. And they try to make up 5 to 10 intervals from that. So if the range of numbers is, let's say, 49, there's a difference of 49, well, I might round up to 50 and say, okay, if I make 10 intervals, they'll each have 5 in it. Or I could make 5 intervals, they each would have 10 in it. So that's we're talking about using a round number. So we take the range, the biggest number, take away the lowest number. We look at that. We kind of round that to some amount, and then we divide that rounded number up into different intervals. And each interval needs the same number of units. So if it was 1 to 10, I can't suddenly do 11 to 30. Everything in our example had 10. But we couldn't have 5 numbers and then 10, 10, 10, and then 7 later or something like that. That's it.